So this session is Advanced Lync Voice Interoperability. It goes into depth on aspects of which we've identified that cause issues with voice interoperability with PBXs. It is a level 400 session. It builds on Jamie's level 300 that was at 8:30 this morning. If you have any questions, I'll pause at some point halfway through, but please use a microphone. It is a recorded session, and it is handy for people reviewing it afterwards if they can hear the session questions even. My name's Adam Gent. I work for a company called House Interactive. I'm also a Lync MVP. So to start off with, and this is repeated at the end, please fill out your evaluations for the sessions. An awful lot of people haven't for previous sessions this week. We do find it incredibly valuable to have them. Some of the evaluations supplied at last year for this session have gone into improving the deck this year. So please do provide feedback, good or bad. We do read it, we read all the questions, we read all the content. The only thing to note is that when we get them, they are anonymous. So if you do put questions in there you want answers to, please put your email address into the question area as well in the feedback area, as it's the only way we can reply to them. So what are we going to cover in this session? Well, brief introduction. We're going to look at trunk configuration options. So this is how we set what and how we configure with the PBX. We're going to look at media bypass, and then we're going to look at interoperability with Cisco. We're not going to go as detailed as we did last year on this in terms of configuring it all on the fly, but we're going to look to prove that bypass still works with the latest CUs, and also look what happens if there's small changes, which then completely change things, but you may not realize until your network grinds to a halt. So this builds on the Voice Infrastructure Fundamentals session, which was Jamie's session earlier. That was definitely last year's session title. I think he changed it this year. And it's designed to provide deeper feedback into what we have. There's still some seats dotted around if you want to sit down. So, to prove it's a level 400 session, we'll start with the easy parts, the SIP invite. So, the fundamental part of any interoperability between Lync and a PBX is the messaging that goes between it, which is SIP-based messaging. And that always starts off with a SIP invite. It's the only SIP trace we're going to look at today. I'm going to look at it for a couple of reasons, because it's usually this which you need to look at if you start getting issues, if the number's not calling or if you're getting the wrong information. So the SIP invite, at the very top of the invite line, it specifies the called number. Some PBXs will take this in an E164 number, like it's shown there. Some won't. Some require this to be translated into a 4-digit extension, a 12-digit number, whatever it may be. Now, we can actually manipulate this within Lync. It's done on the trunk. It's the outbound called number manipulation. And it was added in 2013. It comes in very useful. It was there in the end of 2010 as well. And it allows us to manipulate that number. It was one of the big issues we had with connecting with any PBX. So we used to just send the full E164 number with a plus. We provided the option to strip that plus at one point, but it was still it was still the full number. And unless the PBX could manipulate that, we had problems. We can now strip that back down to whatever's needed. Whether that's strip it down, change it completely, we can do whatever we want with it. It's just a regular expression. So the from line. This is the from number. This is who we're calling from. Again, we can manipulate this as well. So here it's in a E164 format, but we can change it to whatever we want it to be. So if we're doing an extension to an extension call between Lync and somebody still on a PBX extension, we may want to change this just to the 4 digits so that when they hit redial, it redials back properly. They see the name properly. It's small things like that which make doing an integration, especially pilots, very important because you're not changing how people work. They can still call back that person as if they were on an Avira, Cisco, Mitel, or ShoreTel system without any problems. So the contact line. This is the SIP server, so Lync in this case, that the messaging came from. This one was an encrypted communication. The transport was TLS, but we also support TCP. And to most PBXs, we actually really only support TCP, as a lot don't implement TLS to the full standards. We support TLS to all the approved gateways, whether that's the basic or enhanced gateways. We support TLS all the way through if needed. So now we get into the second part of the invite, and this is called the SDP. This is what describes the voice session we're about to have. So in here we've got the initial audio line. This is whether we support, this is the type of RTP we support, whether it's encrypted or unencrypted. This part is unencrypted RTP supported. We do this because with a lot of PBXs, they don't support RTP as SRTP fully. So we provide the option to knock that down and just do an unencrypted stream if necessary. This is particularly important for media bypass, because in a normal scenario world, we can do encryption to the mediation server because we own that without any problems, and we can do unencrypted from the mediation server to the gateway. The problem we get is that with media bypass, unless we've reconfigured the system just to support encryption rather than require it, we can't do that end-to-end unencrypted stream. So the next line which we need to look at in troubleshooting is this line. And this says encrypted RTP is preferred. And it's preferred because that's the way the Lync system was left configured. That way, it's if we're doing a peer-to-peer call within Lync, we'll encrypt. If we have to not encrypt because the other end doesn't support it, that's fine. And it's the same change you need to do for Skype integration as well. So it's done in the media configuration part. The encryption lines, and this is where we get a lot of issues with doing TLS to other PBXs. So Lync supports one encryption method, which is the AES part of that line. Some other PBXs don't implement it. Some PBXs implement different ones. And the reason is the RFC behind this doesn't specify a minimum encryption methodology that has to be implemented. You can implement one, you can implement all of them. The problem is the person you're trying to talk to may not have implemented that either. So this is now a large crowd of people at the back of the room. There are seats to sit down. So the next part to note is the codecs we've provided. So between the mediation server and the PBX, and also for media bypass, we only support G711. We don't advertise that we support RTA, or that we do internally. We don't advertise that we support Silk, but now Silk is in the Lync stack for interoperability with Skype. But PBXs don't support them, so we just offer G711. And the last thing to note is a packet time at the bottom. And this is how many milliseconds of data is put in a packet on the wire. Now, why is this important? Because some PBXs have different values. And if you have different values throughout your network, you run into a position where you may have 25 milliseconds at one hop, 20 milliseconds at another, and it just doesn't work. You end up with a very poor audio quality going through. And I've seen a lot of implementations change because someone's decided that they're going to put more data in a packet 10 years ago, and then completely forgot that they were going to do it now. It's not until you start looking at the traces that you actually find out that that's a problem. And it's usually way past the pilot stage as well. So what options do we have to configure interoperability between Lync and PBX? And I've just pulled out a couple, and there's a lot more. There's a lot of things which we hide, well, don't hide, but don't publish through the web interface. So if you've looked at the PowerShell commands for configuring trunks within Lync, you'll see a lot more options, such as mobile trunk support, which is purely legacy and we don't use anymore. There's things in there for not sending pluses, which we don't need anymore because we can translate the numbers. But it's all left in there just for legacy reasons, migration reasons. But it's definitely a place to look when you're looking for things. So we're going to cover off refer, session timers, RTCP encryption, then media bypass in more detail. The reason I chose these ones is the ones which usually need to be changed for one way or another for interoperability to work. It's the ones that the interoperability documents published by Microsoft usually ask us to modify in one way or another. So we're just going to look at why. So refer. It's used for call transfers, and it's used to try and optimize a call transfer route. The problem is a lot of PBXs like Cisco don't really implement it. If they do, they implement it in a way which was fine when SIP was about 6 months old, back in Call Manager 4, 3 days. Now, we're a lot further on. So SIP refer, again, it's RSC based, but hey, what's the point of following the RSC? It gets boring after a while. So we provide two types of refer. We prefer the completely normal SIP refer. And this is where we send the refer message to the PBX which says, here are two calls, link them together, we don't care about it anymore, and get it off our system. We dump the media, we dump the signaling, and that's great. If you've got a Cisco user calling a Lync user, that's then transferring to another Cisco user. Problem is you do that, and the call just kind of dies. So with 2013 and buried in a late CU of 2010, we brought in third-party call control refer. And this was us kind of trying to get rid of the heaviest load of transferring a call, which is the media, but still retain the signaling. So the media is what causes us pain with putting it through the mediation server. It provides a load, it provides pressure. But the signaling, it's not that important. It just sits there at the background and ticks through, but it's not putting that load on any of our equipment. So this was kind of the best we can come up with, rather than just saying, turn it off completely and we'll just keep managing the media and the signaling. It's now going through 3 Cisco phones, 2 Avaya phones, somewhere in your network in the Middle East. We just keep with it. So what we do with third-party call control is we just send invites out as if we're doing a normal call forward. I'll just change a call. And in the STPs, we just specify each other's endpoints and then just try and dump off the media. If it succeeds, we retain the signaling. The signaling still throws through the mediation server, but that media is now off our system. That could be then become peer-to-peer between 2 Avaya phones, or it could be routed through a Cisco MTP. It could be going out to the PSTN, but we've removed it from us. It can be going through an unqualified gateway which doesn't support refer. The other option is just to disable refer completely. The problem is we get some strange things happening if we do this. For example, the minute you try and transfer a call, it becomes non-bypass. So if you've got a bypass call between 2 Lync clients in a branch, they transfer to somebody else in that branch with a third party involved, such as a Cisco phone or a Avaya phone or a PSN call through something which just doesn't support refer. We get a position where that media then has to go through the mediation servers. So that may be coming all the way back to your data centers over your WAN connection. And it may even get blocked by some CAT configurations as well if that's still too overloaded. So if you've had issues with refer in the past when doing integration, take a look at third-party call control refer. It's referred to as 3PCC refer in the GUIs. And it's a way of first trying to optimize that media path while still working around the limitations that get thrown at us. So the next one is session timers. This is a great one because you do all your testing in the lab, you do a call, it works for 2 minutes, and you go, great, it works. Problem is, after 15 or 30 minutes, depending, your call just gets cut off. I've seen so many times where that doesn't happen until you actually get into a pilot stage because you've never done a call that long in the lab. You roll it out, your first test user, they do a call, middle of a conference call, and the call just dies. The reason is that even though Lync implements session timer, I'll just cover what it is in a second, a lot of PBXs claim they do and they honor it when we negotiate it, but then they just don't respond. So we think the call's dead. So what session timer does, it's a way of seeing if a session is still alive. We send a SIP re-invite through the half-life of the session to say, is this call still active? Is this still a concurrent call? If it is, we continue it routing. If we get no response, or we get told the call died somewhere in the route, someone's on a mobile phone that's been cut off going from tower to tower, then we just end the call. It releases resources that we have within the mediation server. It stops a call hanging around. But the problem is if the other end doesn't reply and it's a valid call, you get cut off. So for an example, in the Cisco world, we will negotiate session times absolutely fine. The Cisco side will claim to support the session timer. They'll send back the session life, which is about 30 minutes by default. And halfway through that, we issue a re-invite to say, is this session still there? And it doesn't respond to us. So we just kill it, which is great if you're on a boring conference call and don't want to continue. But when there's some C-level exec looking at this brand new toy you just invested in, it's the last thing you need. So it should be noted that if we turn session timers off, we still support answering session timer requests. So if the PBX at the other end wants the session refreshed and we negotiated it, we will still honor that. We'll still respond to it. even if we don't support session timers the other way. This is configured through the PowerShell script, through PowerShell if it needs to be turned on and off, and it's configured on the trunk. You're better off turning it off and having some dead calls hanging around, which don't use up that much resource, than cutting off calls halfway through. Even if you set it to something crazy on the VIA or Cisco end, something like 6 hours, you assume a call's never going to last more than 3 hours, guarantee you'll find a corner case where it does, and it'll be someone you don't want to upset on that call. So RTCP. Again, this is another thing we have loads of problems with interoperability with. So even though Lync supports the RSCs, well, we seem to be the only one. So real-time control protocol, we use it to get statistics about the call. We also use it to see if it's still alive. We actually use it in a very basic way compared to what the RSC says we can. Again, a lot of places will say they will honor it, but they won't. And this one's a lot easier to test. If you're doing test calls and your call dies at 30 seconds on the dot every time, the likelihood is its RTCP is not working on the other end. But you've got to remember this is set in 2 places. We use it for active calls. We also use it for calls that are on hold. Just making sure that you haven't put someone on hold, forgot about them, gone grabbed a coffee, and the other end's hung up. Well, if they're hung up, we quite like to know about it, so we'll just kill the call our end. So if you need to turn RTCP off, make sure you turn it off for active and on hold calls. Otherwise, you're in a position where you can't do anything. The amount of people I've seen that have hit the 30-second issue and have looked and looked and looked. Because RTCP is buried in PowerShell, it's just not been one thing they've looked to turn off. It is documented out there. The integration guides published by Microsoft for interoperability with Cisco and VIA do list it, do follow them. Things may look to work, but odds on they won't. So encryption. Encryption's always interesting. There's 2 types of encryption, signaling encryption and media encryption. Some PBXs will support media and not signaling, and vice versa. Very few actually allow us to do both, and that's usually where gateways are involved. So signaling encryption is TLS. We use it everywhere within Lync. We use it between servers, we use it in clients and servers, we use it during federation. It's turned on by default. It's part of Lync's ability to just say we're secure from the get-go, because it's actually really difficult to turn off now. It's based on certificates. It's why we make you get trusted certificates, especially between Lync servers where both sides have to have a valid certificate and have to mutually authenticate. It's not quite the same with clients. We just assume that they're going to trust our server, which is why we don't use self-signed certificates for the SIP signaling, although we do when users log in. Media encryption is standard-based. It's usually referred to as SRTP, but it's another standard which, well, as we covered earlier, if they don't implement the same cryptos as we do, you can't get anywhere fast with it. So the thing to remember with this is that our signaling always goes through the mediation server, even in a media bypass. So we can do signaling encryption up until the mediation server within Lync, and if the other end supports it, we can do it between Lync and the mediation server and the PBX. But when it comes to media, that can go peer-to-peer in a bypass scenario. Which is why when you're doing testing, you may find out that if you do one type of call, it works, because it's going through the mediation server. And the mediation server breaks that, and we can, if on the next hop it negotiates that encryption isn't supported, then it'll just send it unencrypted. The problem is the mediation server has that luxury. The client, by default, always requires encryption. And therefore, it needs to be configured if necessary. Right. So that was the easy part of the session. Now the fun part, media bypass. So those of you in Jamie's session earlier, you got the very, very easy part of this. Presenting me putting in about 5 more slides into this deck. So now we do the fun part. So what is media bypass? It allows media to bypass a mediation server. It's a concept of trying to keep it as local as possible while stripping back Lync resources from branches, remote sites where there's not good connections, where there's lack of IT resource, where there's untrained staff, or where you just don't really want a piece of kit because it sits on the receptionist's desk and every now and again she kicks it and your calls just fail. I've seen all those scenarios. It's not good. It's easier just to keep the media as close as you can to the calls, it improves the quality, it cuts back on the WAN, sorry, and in general it just makes things better. So let's look at some of the terms we're going to cover. A bypass ID, it's a unique ID assigned to the network. So we're using the network sites the same as you do for CAC in this, and how we configure it. So a site is a collection of subnets. Internal bypass mode is used when we're on the corporate network. And then external bypass mode is used when connecting through the edge. So external bypass mode is now always set to false. It was originally put in for when we supported hybrid voice Office 365, but now that's no longer within the product. We don't set it anymore. No doubt, following the announcement in the keynote, we'll start setting it again at some point. So let's look at how we get these bypass IDs. So I had to put animations in all of these because people couldn't follow these last year, which was one of the things which was highlighted in the evaluation. So we do listen to them, and I've actually learned how to do animations in PowerPoint now. Part of my life I never want to repeat, so I'm hoping I don't have to change these if I do this session again. So to start with, we need to assign the bypass ID. So how do we do this? Well, we look up the subnet of the client. And the important thing to point out is that this is the subnet of the client. It's not the IP address they're on. It's the actual subnet. All that is passed is a subnet ID. So if you've defined sites within Lync and say, I've got an entire Class B network assigned to this office, but you subnetted it into different floors, different sections, that client will never get the right bypass ID. They won't bypass anyway, because we pass back and we look at the actual subnet provided to that client. So if you subnetted it all into Class C networks, you've got to enter all those Class C networks within Lync. You can shoot your networking guy for doing that, because he probably did it because he was bored one weekend for no apparent reason. I've seen ones which have gone far too far because somebody wanted job security, usually contractor. We change it slightly when it comes to gateways. For gateways, and the IP address listed in the SDP we saw earlier, for where we're sending the media to, we look at the actual IP address, because there's no way for us to know the subnet of that. So this is where you may get into a position where inbound calls may just about work with bypass, because we're looking at based on the actual IP address. But calls going the other way around won't work, because we're looking at based on that subnet. So once we've got the subnet, we then look at the site associated with that subnet. And this site can have a whole selection of subnets. So there's 200 subnets that your network guys now made you enter for one site that you don't have any bandwidth constraints in. We've now got that site. And that site is tied to a region. And for those of you who looked at network locations before for call mission control, we do it kind of based on a star topology. So we have the regions in the middle, we have the sites coming off those, and then we have region links as well. And the links between the sites is what we assign the bandwidth limitations on if we're doing CAC. The problem is we actually require those bandwidth policies to force a bypass ID. So if you decided I've got plenty of capacity on my network or an MPLS network, it's all managed, there's calls all over it, I'm not worried about CAC, why do I need bandwidth policies? The problem is without bandwidth policy, the bypass ID is never changed. So you end up with media going absolutely everywhere, and your nicely managed network now becomes so bogged down you can't do anything with it. So the way around it is create a bandwidth policy, leave the limits at 0. It's enough just to force that change to go through. I've got a screenshot showing that later. So if we do have bandwidth constraints in there, we assign the bypass ID assigned to the specific site. Then that bypass ID is issued to the client or the gateway. If there is no link, if there is no bandwidth policy, we assign the one referred to in the region. So all these sites connected to the same region, if there's no bandwidth policy, now have the same bypass ID. If if the gateway and the client have the same bypass ID, then the call bypasses. It may not be what you're intending it to do. Odds on it probably wasn't. So what happens when the client logs in? We log in and we look if the client's external or not. If it is external, we don't assign any bypass ID. Because you're external from us, you're connecting through the edge server, odds on is we don't have a media path between that IP phone line around somewhere and the Lync client. If you do have a network path in there, then I really pity the security of your network. I've seen it in one or two places who have been around since there was Class B networks, or since it existed, and have got an entire Class B or in some cases Class A networks themselves on the internet, and they just allow everything out, which is great. You get one-way speech. Great if you're talking to someone you really don't want to listen to. It's actually not that good if you actually want a meaningful conversation. So we just don't let it happen. We do that intelligence within the product. So if you are an external client, or internal client even, we look at that network subnet. And we decide if that subnet is actually one we want to work with. So we first look in a couple of places. We look if media bypass is enabled. You may not have enabled it. Small sites don't need it. If you've only got a single site, there may not be any point in configuring bypass. If there's no bypass, we don't assign a bypass ID. Then we have this concept of bypass all, which is great if you're a small site, the only site, the media can't go anywhere else. So instead of entering all this topology information, you just say, any call can bypass, we don't care. It's great if you're a small business, one office, one Lync system. Just when you then grow and get a second office, just remember to come back and change this. Otherwise, you'd end up with media everywhere. So if bypass all is enabled, we assign a global bypass ID. Everybody gets it. Again, if the IDs in two calls match, well, they can talk. So then we look if the subnet matches a defined site. If it does, they get the bypass ID for the site or region, depending on if there's a bypass policy in place. If it doesn't, we then have another option, which is actually if it's a non-defined site, well, do we just give it a default bypass ID and let it go? Again, this is handy if you've got one or two small offices that have really limited bandwidth from a site-to-site VPN, and you just want to say, here's the two subnets that I actually care about whether we bypass with or not. So we'll assign it the default bypass ID. You've got a small PBX in that office, and it just keeps the media within it. If that option isn't set, and there's no subnet for it to match to, then we just don't assign a bypass ID. Basically, the calls won't bypass. We keep it fairly simple. So what happens when, now we've got these bypass IDs, it's been assigned to the client, we know how the mediation server is going to look at the bypass ID for an incoming call. Well, what happens with these actual calls? So first, an outbound call. So the client makes an outbound call, and the bypass ID is sent in the SIP invite. So when you come into trying to troubleshoot bypass, getting the SIP traces through Logger or the centralized logging tool, pulling it out and looking at it in Snooper, or if you're really brave, and Notepad, you can see the bypass ID in that invite. So you can see what it's getting, and if you've got the other leg of the call and the two don't match, then odds on you've got a bypass configuration issue somewhere. Usually within the subnets, because either you've not defined the subnet granular enough, you've missed a subnet, which is completely possible. Try asking some network architects what all their subnets are. It takes about a month to get one back. So once we've got the bypass ID as part of the invite, the Lync server then determines the correct trunk to use that outbound call. So trunks are new in 2013, and trunks link between the mediation server and the PSC gateway. And each trunk can have a different configuration. So one trunk may route to a media termination point in a branch. Another one may route to a media termination point in the HQ. Both of them have different reasons wanting to bypass media. If you've got a user in that branch, you want to bypass. If you don't, if they're in the headquarters, you don't want to bypass. So we look at the best one to use. Now, this is purely based on the voice plans and voice routes that you define within Lync. So you need to make sure that you specify the right gateways when you're defining your routing policies. So if you've got a simple two-site topology and you've got using the HQ and using the branch, when you're defining your voice route policy, you need to make sure that that user, if they're calling PBX users in the branch, they go out through the trunk for that branch that represents that branch. And the same for the HQ. And that allows us to get the correct bypass IDs. And the important thing to set is what is called a representative media IP address. It's sometimes referred to as an alternative media IP address. It was covered in Jamie's session earlier. The word alternative is the worst word we ever picked for that. It used to appear as that in the web interface. It doesn't anymore because it's not an alternative address. We don't send any media to it. All we use it for is looking up a bypass ID. So it's an IP address that represents that site, and it can be anything. I usually pick the network base ID. It's something I know what it is. But it can be anything within the subnet. But we don't send any media to it whatsoever. It's used for routing decisions only. So once we've got all that, we look if the trunk's enabled for bypass or not. Again, it may not be. It may not need to be. If it isn't enabled for bypass, then the only option we send for media termination is the IP address of the mediation server. And that's a PSTN mediation edge. So if you configured your mediation server in Topology Builder to use one IP address for the Lync side and one IP address of the PSTN, you need to make sure that the PSTN side can talk to your voice estate. That may be a separate VLAN, it may be non-routable VLAN, it may be the best thing you can negotiate with a person who still thinks he controls voice. Whatever it may be. If you are unable for bypass, we need to look for this representative media IP address. The great thing is, one part of it is set through Topology Builder, the rest of it is set in PowerShell. So the initial trunk that's created when you define that gateway, you set the representative media IP address in the Topology Builder. But that's the only one you set in there. For every trunk you create under that, you have to go into PowerShell and set it on the trunk. It doesn't inherit, and there's no other way of doing it. Takes a bit of hunting around, but it's definitely in there. It's a set CS trunk configuration. So if it does have a media IP address, we look at the media bypass ID based on that IP. We override what's in the SDP, but only for this part, only for the bypass ID. Because we know that this media is going to end up in that site, unless something really odd has happened. So we override it and we say, right, for the bypass decision, we're going to make it now. Because the problem we get is that we have to make this decision very early on. We don't know what's going to come back from the other end. So we can't say that it is in this site, but we believe it is because that's how we've configured it, we know our network. If that isn't set, we use the bypass ID as a signaling IP address. So the reason we need the representative IP address is because media, we want to stay locally in the site and media termination point, but that signaling could be centralized, a VIA system, a call manager, a GenBat, whatever it may be. But the signal IP address is all we've got to go on. But that may be in a data center, and we want everything staying within a branch, which is why we have the representative address. And then we do the simple part. Do the two IDs match? Does the bypass ID match that of the client? If it does, we will bypass. If it doesn't, no bypass will happen. So if they do, we send the invite to the gateway that contains a client IP address of the media termination. We say you can just do it directly. If it doesn't, then you end up in a position where we just send the mediation server address. And this is where the bypass decision is made very early. It's made before we know what the other side is giving us, which is why you have to use the representative addresses. If we did it any later, we wouldn't be able to do early media, which is where you then get that delay of setting up the media stream. And that tends to be even worse. So an inbound call. Well, with an inbound call, we do it differently because we know it's an inbound call to us. That initial invite has the IP address of where that media is coming from and where we have to send media to. But the first thing to look at is this a TLS call? If it is a TLS call, we match the trunk made based on the FQDN and the port. If it's not, we match the trunk based on the gateway IP address. And it's one thing to note, because if you configure TLS but define all the gateways with IP addresses, then this isn't going to work. We don't do reverse DNS to look it up or anything. We just go based on the FQDN that's given to us. So then we need to look if media bypass is enabled, and this is the trunk that it came in on. The trunk we just match our IP address and port to. And it's important that it's an IP address and port as well, because that gives us a unique tuple. It gives us a particular port it's coming into, and we can listen on multiple ports if needed. So if bypass is enabled, the call will not bypass. We go through the mediation server and we just deal with it. We'll send the invite to the client, and it will have 2 SDPs in. Those 2 SDPs are for the 2 versions of ICE that we support within Lync, the newer version and the old one which we supported in OCS. We leave both in there for backwards compatibility. If we do support bypass, we look at the bypass ID of the media address that is in that SDP. And this is where we don't look at the subnet associated with it, just that IP address, and we find the closest subnet that matches. In other words, the smallest subnet. If there's a class B defined, but there's a class C it will fall into, it's a smaller subnet, it's a more granular subnet, we'll match that one. And then we send the bypass ID and the SDP which was given to us by the PBX, as well as the 2 SDPs to the mediation server. And the reason we send all 3 is it's a client that makes that bypass decision, because we don't know the bypass ID of the client, because you can have 5 clients logged in. You could have a laptop at home, you could have a desktop in the office, you could have a mobile phone logged in, you could have a tablet logged in. We don't know what device you're going to answer that call on. The device you answer it on may be the one in the local office. It may be the one in the headquarters because you're visiting there for the day and you left your desktop logged in the branch. We don't know what it is, so we send all 3 SDPs. And we say, look, this is the one if you want to bypass. These are the other 2 if you need to use them. And we set that up so we're not blocking media flowing. The quicker we can get media flowing, the less lag, less it is of picking up the phone and having to wait for 2 or 3 seconds to actually start a conversation, unless you're using response groups and IP phones, but we won't go there. So the client checks if the bypass ID matches, because it knows what its bypass ID is, it knows which ones you've answered on. So this happens the moment you click that toast pop-up of, I want to answer the call here. Once we do that, we send a response back going, yes, I want to bypass. This is my bypass ID. Let's go for it. Otherwise, we say, no, we don't want to bypass. We're at another site. We'll go through the mediation server. In which case, we then complete the negotiation as quickly as we can. That data is sent through the mediation server. What's been done in the background is that since we sent the SDP information for that call to, say, it may go through the mediation server, we've already set up the path through the mediation server. We've already opened the ports, which we lock down to the IP addresses we're expecting them from, so that data is ready to flow. So all it is a signaling delay. If we decide we're going to bypass the call, the client sends a response back to the mediation server with this A equals X bypass in there. And that just indicates we're going to bypass the call. What you'll see is if you do actually look at SDPs, you'll see loads of these A equals X lines. And they're basically lines within the RSC which says we can put whatever we like in there. There are additional fields that we can fill in with whatever information we want. So we use that within Lync for passing the bypass ID, passing information like we're going to bypass and all that type of thing. So as I mentioned earlier, we use the site and region configuration. It may look from the outside this is only used for call admission control, but it's not. We use it for bypass as well. So it relies on the regions, the sites, and the subnets. And just to emphasize again, the clients use those subnets and the bandwidth limits. The thing to remember that bypass and call admission control are complementary. If you have one, you can have the other. Unlike what some of our competitors may say about the product, that's how it's designed to work, and that's how it does work. The fact is that if you've got call admission control going, then you don't want media sent across there, so which is why they're complementary. So CAC provides a way of limiting the amount of traffic over a WAN connection. We use it to say we only support X amount of bytes or kilobytes going over this connection at any one time. If there's 5 calls that use all of that, then we'll just block any of the calls from going out of the WAN connection. We may find another way to succeed that call, such as routing over between edge servers, routing over the PSTN. If that's what you decided, you'll take that hit on the toll charge. Some of the SIP trunking providers are very nice and actually don't charge you for that part if it's within your DEL plan, which comes in quite handy for rerouting if needed. Yes, the call quality is slightly worse. It's not that high fidelity call, but it makes that call succeed. Media bypass is a way of keeping traffic off these WAN connections. So it's a way of saying, let's keep everything as local as we can. We don't even get caller mission control involved in those decisions because we're not using it. We don't argue over that few case signaling which is going to go over the WAN connection. We don't care about that. That's not what bogs down the WAN connections. It's somebody opening a large WAV file of a company meeting or loads of media streams, or a friend posting a video internally which they should have put on YouTube instead, and everyone pulling over. The only way this happens in slightly different ways, if you check that always bypass one, it's not supported when using CAC, because the two just don't go together. How can you limit where you're sending your data but then force everything towards bypass? The two just don't go together. So if you check that always bypass, you'll find all the CAC enablements are all grayed out. It's purely because the two just do not go together. So the site and region is configured with the sites, the subnets, and then the bandwidth policy. And the bandwidth policy can completely blank. Just make one which you know the name and assign it. If you're not worried about the limitations over the network. If you're not issued about caller mission control whatsoever, we just need it to force that bypass ID to change. So let's take a look at what happens within the client login. So these are just some of the, following on from the traces, these are just extracts from the logs that you may see when you start looking at logs to try and see what's wrong. So this is what's sent from the client to the server in the subscribe message. And we can see the subnet in there, and that's generated from it. So my actual IP of the client is 192.168.1.150. But it's a Class C network, but it doesn't send that, it sends a .0. So network ID of that subnet. That's what has to match your subnets you define in the network setup. And then we send the information back from the server to the client. And this is sent in a SIP OK message. It's buried in a lot of other information because of all the inbound provisioning, and there's several of these that go over for different parts of the inbound provisioning. So it's done in the media configuration section. And here we've got where the bypass is enabled, whether we use the internal bypass, and the bypass ID. So the bypass ID is a long number at the bottom. So in a call setup, these are the type of information you'll start seeing in there. So this is where we look up, so this is an outgoing call, and you can see here that it's looking at the bypass ID based on that representative media IP address. So I configured that my branch, the representative media IP address is 192.168.2.0, but actually in the trace, in the SDP, it's probably 192.168.1.30 or something, because that's my signaling location. That's where my PBX is. But this is, I know this is going to the branch, that's what my routes say, therefore we'll assume this is going to be answered in the branch. We can't get any more complex than that. Yes, on the PBX side they could have moved things around, but that's a pain, it doesn't usually happen. For an incoming call, we use the remote address. So in this case, it's 192.168.1.30. And this is the IP address of the call manager in my lab. So we're using the IP address that's actually sent in the SDP. This could have been 2.30, which is the MTP in the lab, if this was a branch call. And we're looking for a best match, so the line under it. The best match for it is this /24 network. And then the bypass ID that comes with that. And it also nicely says if media bypass was selected or not. So where do we find the bypass ID? Again, it's buried within PowerShell. It's not bubbled up through the web interface, but it's easy to get to within PowerShell. We use the get CS network region to get that region level 1 that we use if there's no bypass ID associated. And then the get CS network site to get the individual ones within our few defines. In our case, is the HQ and and 2 branches. So as you can see, the HQ and the branch one have got a bandwidth policy assigned, that forced bypass ID change, which didn't have anything in. And you can see they've got different bypass IDs in the region. But that bottom branch 2, that doesn't have that bandwidth policy assigned. And it's inherited that one from the bigger region. So if I had 10 more sites with no bypass ID changed, I would end up with media going where I really don't need it to go. And it's important to remember, it's what causes a lot of support calls and a lot of aggravation because they just don't think that a bypass policy is needed because they're not doing CAC, which is completely understandable. So we're going to take a look at interoperability between Lync and Cisco Call Manager. Why are we using a Cisco Call Manager? It's the only thing that can get easily to run on Hyper-V. And it is Call Manager 4. Because from 5 and above, they lock it so it only works on VMware because Cisco just doesn't seem to want to play nicely. Worth pointing out that Lync doesn't care the virtualization platform, so Hyper-V, VMware, Citrix, it'll work. We're not fussed. So interoperability between Lync and Call Manager, actually this could be Lync and any PBX. It always sounds a lot more complex than it is. Usually that's a telephony guy who's petrified of losing his job, or the third-party company you've got that you pay a fortune to support that PBX. There's a lot of money that can be clawed back from those areas. But you need to plan it properly. You need to understand the dial plans. You need to understand how it's configured. You need to understand where these media termination points are. You need to understand where the media flows. You need to make sure that on the PBX side that media doesn't flow from one site to another for needless reasons, because that's taking bandwidth you want to use for Lync as well. And stick to the Microsoft document-supported topologies. We know that if we say that Call Manager 7 is supported, which we've just tested with Lync 2013, we hope the later versions are. But as pointed out in Jamie's session this morning, we have found problems with those later versions working due to changes that Cisco have made. So just don't assume that because Call Manager 7 works, 8, 9, and 10 will work. And that's not true. They should work, but there'll always be some corner scenarios where you run into problems. And make sure you test this. Make sure that you do a call that's longer than 30 seconds. Do a call, leave it going for 3 hours, go for lunch, go home overnight, go to the pub, whatever. But leave it running and make sure it's still running in the morning. Because that way you know that this call is going to continue, that something isn't going to kill it halfway through. And test it and check the logs and make sure there's nothing in the event logs which have strange red warnings in and whatever else. It's not worth spending a lot of time trying to force TLS to work because you've read something which says it will. If it doesn't work, just use it without it. Odds on is on your existing PBX, encryption is not used anyway. If it is, it's for some very particular scenarios where you definitely want to deploy Lync anyway because we just provide it all by default. So let's just take a look at kind of where we've moved with the interoperability with Cisco in particular. So Call Manager 4 was the first PBX we actually said we supported. And that was with 2007 R2, and that was basic integration. And to get that one working is when we made you change the configuration file to remove that leading plus. You can have it in through PowerShell, but pretty pointless. Just use the transformations just to change them to whatever's needed. And then Call Manager 5 and 6 came around that weren't widely deployed. And Call Manager 7 came around, which then introduced E164 support. So we'd had it for about 5 years by then. But Cisco finally got around supporting E164, which meant we could send that plus. It meant that they could do transformations to change and manipulate them where else was needed. But so could we. By then in Lync 2010, we'd had outbound call number translation. We had brought in media bypass. We had brought in call admission control. All incidentally things we usually do within the product. A lot of PBX, you need additions to do this type of thing. And we don't charge you for them either. And then Call Manager 8 and 9, nothing's really changed for us apart from the broke a few things. But we can integrate to an extent. Then Lync 2013 is really where we kind of, probably for the most part, finished our major changes to the mediation server. We always do some bug fixes, some tweaking, but we haven't had any major new features in the CU so far when it comes to the mediation server. The biggest change we've done is added Silk into the media stack for Skype interoperability. So with Lync 2013, we added the ability to translate that outbound calling number so you can easily hit redial on a PBX phone. Third-party referral was introduced. RTP latching was introduced, which is a really fancy way of getting RTP to work through NAT. We put it in for SIP trunking providers, where if you don't have an intelligent enough firewall to open the right ports, it works quite well getting through NAT. And then we also added in things like call history and P-asserted identity were introduced. And these are just ways to pass additional information between Lync and the PBX. So the hops that call's been through is very useful for call billing applications. So they know that it came in through an external call and was transferred, then went somewhere else. And fast failure was introduced, which is the ability for us to say that if you try a gateway and it doesn't respond within the next second, just to give up on it. Don't wait for a message to come back or anything, because we may get halfway through and it just stops responding to us. The fast failover became hard-coded in one of the CUs and broke a few things. So we then brought in as a configuration option. As some systems are slower, if you're connecting things over a slow link, that 10, 15, 20 seconds or milliseconds is just not long enough. So we're going to take a look at just proving the bypass works and just what happens when we do a few changes. So this is what this small Cisco lab looks like. It's all running on Hyper-V. It's back in the Microsoft booth area. The only painful part is it's got Call Manager 4 in. So we've got Call Manager 4 in what we class as the headquarters with an MTP, and then we've got an MTP running in the branch as well. These are all software-based MTPs. There's no Cisco hardware in this apart from an IP phone. And we use an RAS as a basic router between them. So we'll take a look at what happens with the media flows and all of this. So this is where the one on your left is Lync branch to a Cisco branch. So this is a bypass call. So this is a Lync user calling a Cisco phone, or vice versa, both in the same location. So the green path is the signaling, which takes that long-winded route from the Lync client to the Lync front-end server to the Lync mediation server to the call manager, and then to that Cisco phone you're ringing. That's what tells it to ring. But the media stays locally within the branch, and that's what we want. That's a 120K voice stream, or whatever it may be, that you don't want leaving. It will only ever be G711. Lync doesn't support G729, or various other protocols, because if it's keeping the branch, there's no point doing G729. It destroys the call quality, it puts more load on it, and there's far, far better ways of doing it. And then the other one is what happens if the client is calling someone in the headquarters. So again, we're in the branch, and the media follows a very similar path to the signaling, apart from we go directly from the Lync client to the mediation server. We don't go via the front-end server. So in the Lync world, all signaling goes via your mediation, the front-end server you're connected to, including all IMs as well. It's all done through the signaling stream. But the media will flow directly to the mediation server, and then to, in this case, the call manager, because that's where the media termination point is, then to the extension. And that's the basic flows we're just going to see, which hopefully work in the demo. They were working earlier. We'll see if they still do. So I think we're on 4. Or maybe not. 3. So we're just going to look what happens when we put some calls in. So we've got Wireshark running. I have a bias towards Wireshark, I always have. So let's see what happens when the branch Cisco phone calls a Lync user in the branch. So as you can see, we now have UDP traffic going from the branch MTP to the client in the branch. So this is all local. This is going between this laptop and this phone via the media termination point. The mediation server isn't involved in this. It's not carrying any of that weight, and it's not pulling anything over the WAN connection. We keep it all local. If we wanted to, for example, get someone in the headquarters to call us, then we get to a position where we're going via the mediation server. In this case, we're going from the client to the mediation server to the relevant MTP, and that's where the media is flowing. So now we're putting load on potentially on our WAN connection in this case because we're in the branch. Just to prove it works the other way, since this isn't smoke and mirrors. Again, we get the media flowing as we would expect from the MTPs to the client and vice versa. One of the nice features in Lync is the ability to actually show where you are in the world and pick it up automatically. So this is actually picked up through the E911 based routing technology we put in. And even if you don't use E911, it can be very handy if you have a mobile workforce to define the sites and subnets, and it is a separate sites and subnets, just to be able to easily tell if someone's in the branch or whatever they may be. If you've got a highly transient workforce, it comes in useful. Stops people walking to their desk to look for them if they're not there. So if we move this branch user who is on a day trip to the headquarters, just move them over quickly. So now everything should happen in reverse. If they're calling someone in the headquarters, we should bypass. If someone in the headquarters is calling them, we should bypass. If someone in the client, in the branch is calling them, we shouldn't bypass because they're no longer there. And this is one of the nice things about Lync is that it's personal to you. It moves with you. The bypass IDs change, they're not hard-coded. You've still got your same number no matter where you are. So it becomes very handy for if you need to travel around. So if you just look at a call between the two branches, which a minute ago was bypassing, now's not, we're going through the mediation server. And the good thing about this is administrator hasn't had to change anything. These people can move around, we don't have to change configurations. On PBXs, you may have to change the complete site they're associated with, even if there's extension mobility for this to work. It puts load on the help desk, it puts changes in which aren't needed. Whereas with Lync, we don't care. You can move around to your heart's content. Work from home, work anywhere. It just works. If you just look at that within the HQ, I remember the number. So now we're in the position where we're doing bypass again. Calls between my client, which is now in the HQ, and a Cisco phone within the HQ. So that's great, but what happens if people start changing things? So it's working fine, it's how you designed it to work. You go on holiday, you change jobs, you do something, and someone suddenly decides, actually, we should have encryption on for everything. It's how the product's supposed to work. And let me just enable it because it takes a minute or two to come through. So what happens if someone turns on encryption? Well, the call will still work because as we discussed earlier, it'll just go through the mediation server. Lync adapts to its configuration. And if you change it so that you require encryption, well, apart from Skype not working, these calls will still survive. They will still work. They'll work to their heart's content. The problem is they're now doing exactly what you didn't want to happen. They're now going over your WAN connection. And that's not visible unless you're looking in the QE reports regularly to see if calls are bypassing, or you've got third-party reporting tools to alert you to it. You don't need different because nobody's calling your help desk saying this call's not working. All you're suddenly going to see is the traffic over your WAN is going to spike. And you end up in a position where you can't, you're just maxing things out, especially if you haven't put in call admission control. Because you never needed it, you're bypassing, the load was never there. You either end up with everything going between your edge servers or a large bill for everything going via the PSTN. So hopefully, this had enough time to change. Let's just try and force it through. So as we saw a minute ago, a call between, we're still in the headquarters, a call between the Lync client in the HQ and the Cisco client in the HQ went through media bypass. Well, let's see what happens when we do the exact same call. And hopefully, this will work. It takes a minute to come up because we just restarted the mediation server, so it's the first one to come through. And now we see it's going through the mediation server. But the call's still working. The end user's giving no indication that the call's failed, but yet now this is hitting your WAN connection, or it's hitting your mediation server, because you have different scaling recommendations for the mediation server, whether you're using media bypass or not. So your mediation server is either ground to a halt, or your WAN is really carrying some traffic. And it's one small change, but it's one small change which has a massive impact. There are other ones I can turn on and show you, such as someone enabling the session timer. The problem is I'd have to be talking for another 15 minutes. So it's not. And if I just set this back again. So I guess the final thing to really show is that this hasn't been smoke and mirrors. I could have poisoned the DNS, I could have done whatever to it. So once it's reset, we'll get a call going up, and I'm going to kill the NIC on the mediation server, which kind of brings an end to the demo because I can't turn it on again. The reason I'm killing the NIC is because if I shut down the mediation service, we cleanly kill all the calls. So if you're in a scenario where you're doing media bypass for everything, can you think you can quickly reboot a mediation server without anyone noticing? They'll notice. Because the minute that service goes down, we just kill everything. Because we cleanly shut it down. So let's see if I've given this enough time. Nope, still not enough time. Give it another minute or two. While we're waiting for that, does anyone have any questions? If you do, please use a microphone. Listen, I always get the session when no one asks questions. I think it's because you're all asleep. Although I do have some $10 Skype cards to give out to some people. If not, I'll just use them myself. Got to be some perks to doing this job. Very few others. Yay, bypass call. So let's just kill the NIC card and terminate this once and for all. Okay, so that's dead. Yeah, okay. New versions of Wireshark is dreadful. And the media still keeps flowing if Wireshark would actually let me show it. Unfortunately, it won't. I don't like Wireshark anymore. See, the Microsoft people doing this might actually making me use the Microsoft networking tools. Right, unless anyone has any questions?
Yeah, you had mentioned RTP latching and fast failover for the Cisco integration. Do those benefit other integrations as well?
They're not actually needed for the Cisco integration. RTP latching was brought in for SIP trunking providers for the main reason that there's usually NAT-based firewalls in the way. It just provides a way of failing through it, and fast failover isn't usually needed in a Cisco environment unless you have a slow WAN connection.
Thanks.
Right, that's one person robbed me of my free time on Skype. Anybody else? Excellent. Thank you, everyone. And please remember to fill in your evaluations. Otherwise, I get shouted at. And it is handy to know what we did wrong, what we didn't.